We have reached lesson 7 of the chemical bonding storyline. This is the midway point. The storyline is titled, Why Do Some Things Get Colder or Hotter When They React? I've chronicled all 7 videos before. Lesson 1 involves a highly endothermic chemical reaction. Lesson 2 involves the solvation of potassium chloride, another endothermic reaction. During lesson 3, students get a chance to model this solvation reaction. In lesson 4, students are thinking about how can we model the connection between atoms. In lesson 5, students use magnets to model this connection. In particular, how to break the connection between atoms. In lesson 6, students are dissolving additional ionic compounds to evaluate whether all connections between atoms are of the same strength. But this video chronicles lesson 7 of the chemical bonding storyline, which takes us back to that first lesson. And for this lesson 7, students are answering the question, why did barium hydroxide and ammonium chloride, when mixed together, absorb so much energy? This lesson took 2 class periods to complete. My class periods are up to 50 minutes, and I taught this particular lesson during the second quarter of the school year. For this lesson, students used colored atom cards to manipulate the various connections and model what happened in that particular beaker. Here you see 2 of my students spreading all the different atom cards apart and putting them in the correct connection for the reactants. They used springs to mimic the ionic bonds between the various ions. In order for this reaction to occur, these ionic bonds then need to be severed so that new connections can be formed. The products of this reaction are barium chloride and ammonium hydroxide, as modeled here. Upon this modeling exercise, students can then be ready to answer the question, why does the temperature drop when barium hydroxide and ammonium chloride are mixed? As illustrated by the very cold emoji. The lab handout underscores 3 questions for students to ponder. Is there a difference between the motion of particles in a solid versus a liquid and versus a gas? Second, is there a difference between the motion of particles in a warm versus a cool solid? Third, where is the kinetic energy, as illustrated by this blowtorch? Where is it coming from to break the bonds between the atoms? So indicated again with these atom cards, strong ionic bonds connect ammonium chloride and barium hydroxide. The 3 blowtorches mimic the severing of these ionic bonds. Once these ionic bonds are broken, we've reached a transition state, which enables new connections to be made. These new connections are evident from the formation of barium chloride and ammonium hydroxide, held together by weaker ionic bonds, which results in a lower amount of energy release, as indicated by these smaller 3 blowtorches. Now students should be able to answer, why does the temperature drop when barium hydroxide and ammonium chloride are mixed together? If much stronger reactant bonds are broken, which requires energy, and much weaker product bonds are formed, indicative of a smaller amount of energy release, then the reaction gets colder. To enable students to form that connection with all the 7 lessons, we've turned to our driving question board. I'm showing you here the first set of a total of 20 questions, and all these 20 questions were raised by each and every one of my students. To focus on the third question, does the size of the marble we used matter when breaking the bonds? This brings us back to lesson 5, which models the breaking of chemical bonds using magnets and metallic marbles. The second set of questions, I'm highlighting question number 10. In an exothermic reaction, I know that bonds are made, but doesn't that still require energy? And what's highlighted here is the exothermic solvation of sodium hydroxide, which results in a temperature increase. The third set of questions, I'm emphasizing question number 11. Why do some reactions get cold and others get warm? We're seeing here a reaction from lesson 1 where students are mixing pink lemonade with baking soda and some water, resulting in a temp drop. The last set of questions, I want to emphasize number 16, are all bonds able to be broken, or can some stay bonded? For example, is it true that some ionic compounds have a more difficult time to dissolve in water because their connections are so tight? After some pondering over all these 20 questions, my students came up as a class with 2 new questions that we want to bring into the second half of this chemical bonding storyline. The first of those 2 questions is the following. Which type of reactions are more spontaneous? The ones that cause a temperature decrease or the ones that cause a temperature increase? And the second one is, how does the atomic mass of a given molecule affect its intermolecular forces, and thus its melting and or boiling temperature? This is a pretty detailed question, and the only reason my students were able to come up with this one is because I thread this chemical bonding storyline within my chemistry curriculum, and we had just completed the bonding unit. So again, in lesson 7, we try to answer, why did barium hydroxide and ammonium chloride absorb energy? This is the very reaction of the first lesson of the chemical bonding storyline. And through the modeling of colored ion cards, students can then understand that it requires more energy to break the reactant ionic bonds than the energy that is released when the product ionic bonds are formed, which must be weaker. Which leads us to lesson 8 with the following question. Do all complex reactions absorb energy and make their environment colder? Probably not. The chemical bonding storyline centers around the following 2 next generation science standards and New York State science learning standards, including matter in its interactions and energy change in components of a system. What is the power of these storyline lessons? All lessons are beautifully connected to one another, and the interleaving of these lessons really helps students to remember the concepts associated with each and every lesson, especially after we've reached lesson 7, which emphasizes the midway point of this bonding storyline. All 7 lessons have been chronicled by me. Check the link to the playlist above if you wish to see all the lessons that I've created. If you wish to have these lesson handouts and associated keys, go to the video description below and they can be yours to keep. In exchange for your email, it'll take you to this Google Doc with all my lesson resources, not just the ones related to the bonding storyline. Thank you very much for watching. Bedankt voor het kijken. Tot ziens and see you in the next video.